In an earlier episode, we took a first look at the new ONNX inference node, a node that allows us to use trained neural nets inside Houdini. And today, we want to use this node for something kinda useful. We want to use it for volume style transfer. So starting out with a low-res, sort of bland looking Pyro sim, through ONNX we want to end up at a new, stylized, and in general more interesting and more detailed result, as you're seeing right here. Now, this idea of a volume style transfer is not something that I came up with myself. I first came across this idea in these two papers by Walt Disney Animation Studio and Disney Research. And you can think of the setup that we're going to build today as a sort of very loose, very easy and fast interpretation of the core ideas in those two papers. Now, of course, since the setup that we're going to build today is centered around ONNX and the concept of style transfer, this won't make all too much sense if you haven't watched our first episode or intro to ONNX. So if you haven't done so, please take a first quick look at this and then you're ready to build the setup of this episode. But now let's talk about the plan. How are we going to pull off a volume style transfer in Houdini? Are we going to come up with our own new style transfer neural network that is somehow able to process volumes instead of images? Well, absolutely not. This is way above my pay grade and also not necessary for the core ideas in those Disney papers. So what we're going to do instead goes something like this. First of all, step number one, we're going to take a Pyro volume and we want to cut it up into slices, into single pictures of that volume. Then we take all those slices and we simply feed it through a 2D style transfer model, the same model that we used in the last ONNX episode, and we get style transferred images out of those. Then step 3, we're going to take our style transferred slices and we're going to use them to assemble a new volume. A volume that now has this style implemented in it. And then finally, step 4, we're going to mix it with the old volume and in the end get the new detailed volume through this process out again. So let's finally jump into Houdini and get going. Starting out in MTC, let's drop down a geo node and let's first of all create a Pyro sim, and in this case I'm going to be very lazy and I'm just going to search for Pyro configure bonfire. This is a preset that's going to set up a Pyro sim for us. This is still way too complicated. We absolutely do not need all this right here. This is just there for creating sparks. So let's get rid of this. You can also get rid of all this just below our Pyro solver. So we're left with this thing right here. I want to change some stuff in here up a bit. First of all, I want to have a pig head, the good old pig head, as a base for my fire. So let's first of all drop down a pig head. I want to move my pig head up a value of 1.25. And to make it compatible with my Pyro source node down here, I first of all want to create a mask by feature node. This by default creates a directional mask from the top of my pig head right here. And I can use this with a scatter node, wire this down. Let's use our mask as a density attribute in here, just scatter points here on top. Let's turn off the relax iterations and set the total count to a value of 25,000. And then finally, let's make some room here and then wire this into a Pyro source and get rid of the tube right here. And on my Pyro source, let's set the mode to keep input to use the points that I scattered. Then I want to tweak all those three attribute noises a bit. For all three, change the element size to a value of 0.05. We're done here. And finally, on the Pyro solver, I want to set the timescale to a value of 0.75. I want to add 4 global substeps. And on the fields tab, I want to increase the dissipation to a value of 0.85. And also under the flame tab, I want to decrease the flame lifespan to a value of 0.5. And this is all I want to do for my Pyro sim in the end. Let's take a look at our sim. Let's maybe first of all change our viewport background to black, since this always looks nicer with a Pyro sim. So let's open the display options. Let's go to the background tab and turn this to dark. And now let's hit play on our timeline and see what we get. And I think right here on frame 32, we have some nice looking flames that we can use as a base for our style transfer. So let's keep going here. Next, let's drop down a null, because we're going to reference this Pyro sim at multiple points in our setup. So let's call it, let's say fire. And now let's get going with our style transfer setup. And first of all, the first step that we're going to do is we want to cut up our volume right here into slices. And I could cut up my volume simply along the x-axis or along the z-axis or along the y-axis. However, what I like for this setup a bit more is to cut it up with planes that are inside our camera frustum, that are always oriented to our render camera, because with this orientation we always get the highest quality result out from a style transfer for our current rendered image. So let's first of all create a render camera. Let's pick one view that we like quite a lot. Let's go up to our camera shelf tool. Let's hold Control on the keyboard and let's click that shelf tool. And I want to go to the View tab and first of all change this to a square resolution, because this is also the resolution or the aspect ratio of our style transfer. Just for personal preferences, I want to set the focal length to a value of 80. And I want to move my camera out so that we're just seeing the entirety of our flame volume right here. So something like this. Let's exit our camera. Let's also make sure that we disable this log icon right here so we can't accidentally move our camera. And now we have our camera here and our picette here. And now I want to create planes inside our camera frustum that are inside this volume right here. And this workflow will be a bit strange, but it all will make sense in a second. And the first step that I'm going to do is I'm going to lay down one slice, one grid. And on that grid, first of all, I want to set the right resolution later for my style transfer. So if you remember the last episode about ONNX, the right resolution was 224 by 224 pixels. This is what our model expects. And now I'm going to move this plane to a very specific location. I'm going to set the size to a value of 1 by 1. I'm going to set the orientation to the XY plane. I'm going to set the center to a value of 0.5 along X, 0.5 along Y, and some negative value along Z. Let's maybe start out with a value of -2. We're going to dial this in later. Then I want to create more slices, of course. So let's drop down a copy and transform node, wire this in. And I want to move my copy again with some negative value along the Z axis. Let's maybe start out with a value of -1. And now we have those two planes in a very specific location. And this very specific location is for the last step. This all will make sense in a second. For this last step, I will drop down a point wop, set our display flag here, jump inside, and to finally move those two planes to a camera frustum, all I need is this one magic node, this from NDC node right here. And if I wire this in and wire in the P attribute into the input and the P attribute back into the output, and I zoom out a bit, we can see now our two planes are matching our camera frustum. And what we essentially did here is we created those two planes inside the camera coordinate space, which is a coordinate space that goes from an X value of 0 to 1 and a Y value of 0 to 1 and a Z value of 0 to -infinity basically. Once we create our planes in that space, we can use this from NDC to move it to a camera frustum. The only thing that we need to make sure here is that we have the right camera path entered in here. This is the default Houdini path, so this should all work. So we got our two planes. We should match both of these planes to our fire. So let's ghost our two planes here and let's set the display flag at our fire. And we have to move our first plane a lot more forward. So let's go into our grid and let's enter a bigger negative value right here along the z-axis. And a value of -5 looks right for me. And we also have to set the right distance here on our copy node. Let's maybe try -2. This looks fine as well. And now we want to fill the space between both our grids with a lot more grids. So let's first of all turn up the number here, maybe to a value of 30. And let's copy the parameter up here. And in here, let's write a small expression. Let's write -2 divided by the relative reference to our count. And let's add parentheses around this and subtract 1 from a count like this. And now I have this simple slider where I can create new plane divisions between this first and last plane that we set earlier. So set this back to 30 and now we have our slices for our volume. Now with our slices done and overlapping with our volume, we can now take those voxel values from our volume and write it to our slices. For this I'm going to use a point wrangle and I'm also going to use an object merge node to reference our fire null in here. And again, I'm using object merge nodes to reference my file to just make the setup look a bit more clean. And this goes into the second input. And all I'm going to do on that point wrangle is create a new attribute that I'm going to call flame. And I want to use it with a volume sample function like this. And that volume sample function takes a geostream1 because this is where we input a fire. Then the name of the volume that we want to look up. In this case, this is called flame. And finally, the position where we're sampling from, which is our VP. Something like this. Now we can use this flame attribute on our grids to create a color. Let's drop down a color node, wire this in. Let's set the mode to RAM from attribute. Let's load in our flame attribute. And let's maybe set this to a black body range, which is your typical fire color range, like this. We can kinda make out a fire in here in our grids. To get an idea how this is looking, let's maybe build a quick visualizer by dropping down a blast node, wire in the output from our color node. And in here, let's make sure we're working on points, and let's write a small expression by simply checking if add flame or flame attribute is equal to 0.0. And let's also maybe turn off this backside coloring right here. And now, as we can see right here, we took our original volume and turned it into a bunch of slices. Now we could take all of those slices and simply feed it to our style transfer model. However, with these slices, the first and last few slices will always be blank. And style transfer models don't really like blank images. They're going to do unexpected stuff if we hand them one. So what we're going to do first is get rid of those blank slices. For this, I first of all need a piece attribute for all my slices, and I can simply use the copy node up here for that. Then I can simply enable a copy num attribute. So now each slice has a different copy num on all its primitives. And with this, I can simply do a check with an attribute promote. I can promote my flame attribute from point to primitive based on that piece attribute, that copy num. And I can take the sum of all that flame attributes. And I'm going to change the name. Let's change it to flame underscore total. And let's not get rid of the original. So now each slice has the total amount of flame on that slice stored in this attribute right here. And now I can drop down a blast node, make sure this works on primitives, and write a small expression in here. Add flame underscore total is smaller than, let's say, a value of 0.1, like this. And now we've got rid of the first and last few frames that are simply empty. So now we are finally ready to do our style transfer. And I'm actually not going to rebuild or build that style transfer setup from scratch because I already built the exact same setup that I need in here in the last episode. So what I'm going to do instead is I'm going to open up the scene file of that last ONNX episode. You can also find this in the scene file. And I'm just going to copy this style transfer box right here. And also make sure that you download the style transfer model, this mosaic-9 model right here from this link. And I'm going to paste the whole setup in here and just make sure that I also have this model linked in here and referenced in here as well. Now let's change some stuff up with this a bit. Let's first of all get rid of this box right here. Let's drop down a null, and we don't need these 3 nodes right here because these are all there to set up a color attribute, which we already have. So instead I'm going to wire in this null in here, and in here, and in here, and in here. And we can get rid of those nodes right there. This is our new style transfer setup. And taking a look here at our ONNX node, if you remember the last episode, the first value in this parameter right here is always the batch size. So how many images we can feed to our ONNX node at a time. And in this case, this is set to 1, so just 1 image at a time. So we need to wrap all of this in a for loop. So let's first of all drop down a for loop. I'm going to use a for each named primitive loop right here. Let's wire in the input from our blast right here. Let's set first of all a loop up. Our piece attribute should not be called name, but instead should be called copy num. Our piece attribute from a copy node. Now this should work. And if we set this to single pass, we can scrub through these slices of our volume like this. Then let's wire this into our style transfer. So input goes to the null and output goes to the for each end. And if we now scrub through our slices, we can also see our style transfer working. So we are on the home stretch here. Now we have to work on taking those slices and converting them back into our volume. First of all, we have this slight problem that this is just color data, so RGB values, but for our flame volume, we of course only want single float values, just black and white values. So we have to do a bit of color conversion in here. So for this, I want to use a point VOP again. And on that point VOP, I want to use my CD attribute and convert this to HSV. So let's drop down RGB to HSV node right here. Let's now drop down a vec to float. And with this vec to float, the first input right here should be the hue. The second one should be the saturation, and the third one the value, the brightness value, and this is the thing that we are interested in. So let's use that brightness value and throw it through a ramp. Right in a ramp parameter, let's turn this into a spline ramp. And let's finally write it out as a new attribute. Again, write it out as a flame attribute like this. We should be done here. Let's create a quick visualizer for a flame attribute by simply clicking on the flame icon right here. And now let's play with a ramp right here. We first of all want to make those tendrily lines our brightest part of the image. So let's flip this ramp around and let's up the contrast a tiny bit by bringing this back value up a bit, maybe to a position like this, maybe to a value of 0.8. And this is a ramp that should work nicely for volume in the end. Let's also blur this a bit. Let's drop down attribute blur. Let's work on our flame attribute like this. And let's give it maybe 2 blurring iterations. We don't have to go crazy here. So with our colors managed right here, we can finally turn on our whole loop again. So let's turn off single pass in here. Let's get our slices back. And now let's turn those slices into an actual volume. For this, again, I'm going to reference my flame or my pyro volume from before. So let's go way up here and let's simply copy this object merge node, paste it down here as well. Taking a look at the info panel, we got a bunch of volumes that we don't necessarily need. So let's drop down a blast node. And in this case, I'm just going to keep the density and flame volumes and delete non-selected. If I were going to render this, I also would bring in the velocity volume for motion blur. However, in this case, I'm going to keep this simple. And based on that volume, I'm going to create a new volume. So let's drop down a volume node right here, y in our original volume as a reference. And let's set this up. This new volume should be a float volume, a scalar volume, and it should be called flame underscore style. And I want to set the voxel size right here by size. And taking a look at our Pyro simulation up here, the voxel size is set to a value of 0.02. I want to get a little bit lower than this. So let's halve it. Let's make it 0.01. So we're also upping the resolution of our volume by style transferring it. And then finally, I can take my slices and write them back to this new volume that I created with a volume from attribute node. So a volume goes into the left input, our attribute blur goes here into the right input, and let's select the volume or the attribute that we want to write into that volume, and this is a flame attribute, like this. We can see some stuff happening. Let's maybe make this a bit more visible with a volume visualization node. And here under smoke, let's select our flame style volume, and under emission, let's select our flame style and flame style as well. Let's turn our emission to, let's say, 100, which is maybe a bit much. Let's try maybe 70 or 50. And yeah, I think you can sort of make out our style transferred volume in there. However, this will get much clearer once we start mixing it with our original Pyro volume as well. So let's do just that. First of all, our Pyro volume up here should have the same resolution or the same voxel size as our volume right here. So let's drop down a volume resample. Let's specify an exact resolution and again select size and again set it to 0.01. And now let's finally take our Pyro volume and our new volume that we created and merge both of those together like this. And then finally put this into a volume wrangle. And to mix our volumes, I want to simply take our add flame volume from our Pyro sim and multiply it by our add flame style volume, the one that we newly created. And because this is getting quite dim right here, let's also multiply it with a single scalar. So let's maybe multiply it with a value of 5, and this makes our result a lot more visible. And if we take a look through our camera and compare before and afters, as you can hopefully see, our new volume definitely has this tenderly style and is also a lot more detailed than the volume that we put in beforehand. And you can play with this ramp right here to get the right look that you want. You can also try out different models right here in this ONNX node. And in general, you have quite a lot of options in here to play with. So this is it for today. I hope you have fun playing around with the setup, and until next time, it's cheers and goodbye. If you like what we're doing, please consider becoming a patron of ours, not only for supporting Atagma, but also for access to in-depth courses, like our advanced setups course, which already includes a couple of videos about neural nets, or a completely revamped beginner series with 30 videos telling you everything about attributes, simulations, and so on. Also, let me say thank you so much to all our existing patrons. Without you, this channel would not be possible. Thank you.